the gap between the nozzle and the workpiece. The change in pressure is used to change the level of mercury in the mercury switch box, thereby closing contacts D and E, and these contacts D and E will control grinding wheel feeding. Air pressure of 0.15 bar is supplied by a pump A to the caliper frame B, which has two carbide tipped shoes that rest lightly on workpiece. The air outlet is between the two shoes. This is the air outlet placed between the two shoes. Now, as the grinding proceeds, spring tension moves the gauge head forward. So you can see in this diagram, as the grinding proceeds, the size of the workpiece will be reducing, and the gauge head will move forward because of this spring tension. Pressure when the gap reduces between the work and air outlet, pressure builds in the airline P, causing the mercury to rise in the switch box C. At the end of roughing operation, the mercury touches the contact D. An electric circuit is then completed and a solenoid is energized and finish feeding starts. And grinding continues until the finish size is reached. Gap between air outlet and work further reduces, increasing the pressure in the line. Then mercury rises further in the switch box and electrical contact at E occurs. So when the size of the workpiece approaches the desired size, the pressure builds up and the mercury level rises, and then the electrical contact will happen with the contact E. Then when contact at E occurs, a solenoid is energized and grinding wheel is withdrawn from the workpiece and machine stops. Factors such as wheel wear, variation in amount of work to be removed do not affect the machining accuracy, since the final size of the workpiece depends only on the setting of the electrical contacts D and E using master workpiece. Now we will discuss another type of auto sizing device based on electronic system. We can see in this diagram we have this is based on Wheatstone bridge circuit. So in the circuit we have A, and this system is based on Wheatstone bridge. So in this circuit we have A and B fixed condenser. This is A and this is B fixed condenser, and then we have C and D fixed plates. We can see here we have C and D fixed plates, and in between C and D we have a movable plate, that is E. So this plate E will move up and down depending upon the size of the workpiece. When E is at the middle position, that is workpiece size is equal to the desired size. That means initially we will be setting this system auto sizing device by using a master workpiece. So we have to keep the master workpiece between center, and then we have to adjust the position of this plate E such that plate E is midway between C and D. When the workpiece size is equal to the desired size, capacitance between E and C, that is these two plates, and E and D, that is these two plates, capacitance between E and D are equal and bridge is balanced. So this initial setting can be performed by using master workpiece of the desired size. So after doing this initial setting, we have to remove the masterpiece, and then we have to place the workpiece to be ground in between the two centers, and then we have to start we have to set the gauge, and then we have to start the grinding. At the start of the grinding, there is extra amount of stock on the workpiece. That means this is the grinding allowance. So the plate E, will move above and it becomes closer to C. So when the plate E moves up, it is closer to C, but the distance between D and E will be more. At the start of the grinding, there is extra amount of stock on the workpiece. So this causes plate E to be nearer to C, thus increasing the capacitance between E and C, and the capacitance between E and D reduces due to the greater amount of gap. Due to this, the bridge circuit Wheatstone bridge is imbalanced. Now when the grinding continues, the workpiece reaches the exact size, then the bridge is balanced. That means the capacity, the plate E will be at the middle position when the workpiece size reaches the exact size. Then the capacitance between C and E and capacitance between E and D will be equal, and then bridge is balanced. At that point of time, a maximum current is permitted in the output stage to operate a relay, causing withdrawal of grinding wheel. It is interesting to note that any variations of temperature, humidity, ionization of air, frequency and voltage act symmetrically on both sides of the bit. That means any variation will affect on both the sides. That means the variation will occur between C and E as well as between E and D. So this variation has no effect on the reading. That means these variations will not affect the variation of the